Day 830 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2,996, smallest missing integer greater than sequential prefix sum. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero-indexed array of integers nums. A prefix nums of 0 through I is sequential if for all 1 that is less than or equal to j and j is less than or equal to I, nums of j is equal to nums of j minus 1 plus 1. In particular, the prefix consisting only of nums of 0 is sequential. Return the smallest integer x missing from nums such that x is greater than or equal to the sum of the longest sequential prefix. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we're doing this problem correctly. So, in example 1, our input nums equals an array of integers 1, 2, 3, 2, 5. The output is 6. It says the longest sequential prefix of nums is 1, 2, 3 with a sum of 6. So this right here is the longest sequential prefix, right? Because if we go, it goes 1, 2, 3, but if we go to the next one, it goes back down to 2. So that messes up the sequential part. So 1, 2, 3 is the longest sequential prefix, and when we add all of these integers together, we get 6. So they have a sum of 6. 6 is not in the array, therefore 6 is the smallest missing integer greater than or equal to the sum of the longest sequential prefix. So we return 6 because 6 is not in the array. So let's take a look at example 2 where it gives an example of where the sum is in the array and we have to keep doing more steps. So in example 2, our input nums equals an array of integers 3, 4, 5, 1, 12, 14, 13. The output is 15. Explanation says the longest sequential prefix of nums is an array of integers 3, 4, and 5 with the sum of 12. 12, 13, and 14 belong in the array while 15 does not. Therefore, 15 is the smallest missing integer greater than or equal to the sum of the longest sequential prefix. So in this case, the longest sequential prefix is this right here, 3, 4, 5, right? When we add 3 plus 4 plus 5, we get 12. But 12 is already in the array. 13 is already in the array as well, and 14 is already in the array. So we're going to return 15 because the sum of the longest sequential prefix is already in the array. Then the next integer after 12 is 13, which is already in the array. The next integer after 13 is 14, which is already in the array. So 15 is the next integer that is not in the array after we get the sum. Boom. So first we get the sum, 12, then we see 12, then we see 13, then we see 14, so then we return 15 because 15 is not there. So boom, y'all, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, if there's only one number, the longest sequential prefix consists of that number itself. Since that number already exists in the array, we could just return the next integer after it. So we'll say if nums.count equals 1, we'll open up the brackets and we'll return nums square bracket 0, come outside of that, plus 1. Boom. Then we're going to start the sum with the first element. This will become the sum of the longest sequential prefix starting from nums of 0. So we'll come underneath this, declare a variable called sum, and set that equal to nums square bracket 0. Sorry, y'all. Boom. Hold on. Boom. Then we're going to start checking for consecutive numbers from index 1. So we'll declare a variable called I and set that equal to 1. Now we're going to continue while we have not gone past the end of the array and the current number is exactly 1 greater than the previous number. This finds the longest sequential prefix at the beginning of the array. So we're going to say while, open up the parentheses, I is less than or equal to nums.count minus 1. and two and signs. Nums square bracket I equals nums square bracket I minus 1, come outside of that, plus 1. Boom. Come outside of this, open up the brackets, and we're going to add the current consecutive number to the prefix sum. So we're going to say sum plus equals nums square bracket I. Boom. Then we're going to say I plus equals, plus equals 1. Boom. Now, if the sum of the sequential prefix does not already exist in nums, then it is smallest missing integer greater than or equal to that sum. So we'll come underneath this and we'll say if exclamation point nums dot contains, open up the parentheses, sum will come outside of that. We'll open up the brackets and we'll return sum. Boom. Then we'll come right here and we'll say else. We'll open up the brackets. And if the sum already exists in nums, we're going to keep increasing it until we find an integer that does not exist in nums. So we're going to say while nums dot contains, open up the parentheses, sum, we'll open up the brackets and we'll say sum plus equals 1. Then we're going to return the first missing integer that is greater than or equal to the sequential prefix sum by coming down here. All we have to do is say return sum. Boom, y'all. That should be all she wrote. Let's give it a run. Make sure it runs properly. It's accepted. So let's go ahead and submit it. Make sure it's accepted. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.